Alex Breda. I'm Alex Breda, and our presentation will be 2 minutes of each. Okay? The topic of my presentation today will be Vale gas field lithology. Firstly, I'll briefly talk about the Vale background, and then I'll describe the Cambridge clay rock composition, and finally, I will show the Cambridge clay formation, the core sample, and the lithology column. Vale is an offshore natural and condensate gas field in the middle part of North Sea, exactly located at block 254-6S. The diagram below shows the lithology study area in more details, where the formation consists of a Middle Jurassic branch group located at a Southern Viking graben. Cambridge clay is the main source rock in the area and can be classified as a rich dark gray claystone, carbonaceous, and stripe of limestone. Its grain size can be described by 2 millimeters in diameter and greater than 65 micrometers of quartz, feldspar, and mica. The thermal maturation consists of a kerogen type 3 with a total organic carbon of 4.6%. The hydrogen index varies from 400 to 600 kilograms. And lastly, its relativity in oil varies between 0.9 to 1.3%. Finally, to conclude my presentation, I would like to spend the last few minutes. The last 3 images up here show the Cambridge clay formation. On the top left illustrates the Cambridge clay formation. The Cambridge clay formation showing the rocks. In the middle, the core sample collected from the wells. And finally, the lithology column showing the magnetic susceptibility used to describe the magnetic properties of the rock. That's bringing me to the end of my presentation. I hope you have enjoyed.
Good afternoon, ladies and gentlemen. My name is Sunesi Ajombul, and I'm going to talk to you about reservoir lithology and the reservoir formation evaluation. The Vale gas field is the reservoir. The reservoir is a Middle Jurassic sandstone, and is found in about 3,700 meters depth. And it's of the Brent group, and these are the formations found in Brent group: Tibet formation, Nest, Itai, Ranush, and Brum. These are the lithologies of that various this section of the reservoir, and you can see it's mainly made up of sandstone. This is the facies architecture, and how we determine this lithology, we do that with the use of gamma ray log and resistivity log here. And to read this, you look at the key here. This is the shallow marine sandstone, and you can see that that is found mostly in the Tibet area, and channel field sandstone, which is found in the next area. In this slide, I'm going to talk to you about reservoir properties. The permeability of the reservoir is 350 millidarcy. The porosity is 21, and is a gas field, so it doesn't have API. This is a macroscopic view of the rock and how it appears in the reservoir. But if you go down into the microscopic level, you see this is how it appears with pores in the rock, and which the pores will determine the porosity and the ability of the rock, the hydrocarbon to flow through this rock. This pore will determine the permeability. And over here we have the formation evaluation, and we use the density log to determine the bulk density of the reservoir, and from there you can calculate the porosity. We also use the gamma ray log for detecting the lithology of the rock, and resistivity log to determine the fluid properties of the rock. This is how you run the wireline log into the reservoir, and you measure these various properties. Thank you.
Good afternoon, ladies and gentlemen. My name is Alberto Antonio Rodriguez, and today I'm going to be talking about the Vale gas field, reservoir trap, and seismic. These are the topics that I'm going to be talking about: the tilted fault trap, seismic imaging. On the first slide, I'm going to talk about the reservoir trap formation. Just a quick definition about